In the previous video, we started generalizing. So we start getting the kind of a general formulas for the group of functions that we could use without resorting to calculating the limits. Today, we're going to continue. We introduce two new formulas. Well, the first formula is about constant multiplied by a function. So if I have a function f and I multiply it by a constant and I want to calculate derivative of this thing, it turned out that the formula is very simple. We can just simply take constant out of this taking of derivative business. By the way, the taking of the derivative business is called differentiation. So what this derivative is actually same constant c times the function, derivative of a function f. Now, the derivation of this fact is quite simple. We just need to go back to the definition of the derivative, which is, if you remember, if I had a function, say I'm calculating f prime. What is this f prime? It's a limit. Delta t goes to 0 of the function of f at the point f of t plus delta t minus f of t divided by delta t. Okay. Now, if I do cf prime, okay, like this. So what do I have to do? I have to say cf of t plus delta t minus c of f of t divided by delta t. Now, I'm not writing a limit yet. I'm just writing what I was going after the limit. And what we see here is really just simply there's c sitting in front of both terms. So c can be taken out. And we can rewrite it like this. And now we're going to ask ourselves where this business goes when delta t goes to 0. Well, obviously c goes nowhere. It doesn't depend on delta t. But what you have here, this thing is actually goes to f prime when delta t goes to 0, which means that all business goes to c f prime when delta t start going to 0. And that's what we wanted to prove. All right. One thing is done. Let's move to the next one. The next one is really derivative of a sum of a function. So if I have two functions, f and g, I add them up, and I want to take a derivative. Again, the derivative of this thing is very simple. It is derivative of f plus derivative of g. So derivative of the sum is the sum of the derivatives. Can be anything simpler than that. The proof is very simple again. So you have f of t plus delta t plus g of t plus delta t minus f of t minus g of t divided by delta t. Now what we're going to do, we're going to combine this term and this term. And we're going to combine this term and this term. And split them out. The red terms give me f of t plus delta t minus f of t. We're going to divide by delta t plus g of t plus delta t minus g of t divided by delta t. And now, when delta t goes to 0, what do we get? The first term goes to f prime. The second term goes to g prime. And the whole thing goes to f prime plus g prime. Delta t goes to 0. So this is great. So, but what these two things give us, and the power function, derivative of power function, which we talked about in the previous lecture, it gives us a tremendous, arsenal of tools which we can use now to calculate derivatives of many, many functions. So let's move on. Before we move on, I just want to clarify something. So when we said that f of g prime equals f prime plus g prime, we can actually extend this. You can have three functions, f plus g plus h, and it's going to be going the same way. Or I can add f, g, h, and whatever after that goes. So plus, plus, dot, dot, plus, dot, dot, dot. So it really, if you add many functions and take derivatives, it's going to be the derivative of the sum of multiple functions is the sum of the derivatives of each of those functions. Now you can prove it in a similar way. As I just showed, you're just basically going to have more terms in your limit, and you're going to group it in more groups, and that's it. Or the other way to prove for 3, for example, we can say f plus g plus h prime. We take f of g as a separate one function, and h is another function. In this case, applying this rule for just two functions, we get this. And then we just apply our formula for f plus g prime, which gives us f prime plus g prime, and we already have h prime. So anyway, and you can keep doing this thing, going to more and more terms. Okay, I'm not going to do it. I just want to point this out. So when you have more than two terms, you shouldn't get concerned. You just should apply the same rule as for the two terms. All right. And now the most important thing is we combine all these rules together. Okay? Suppose I have a function, f of t, as, 3t squared minus 5t plus 8 minus 2 over square root of t. Okay, so how do I go around it? I want to find f prime. Well, f prime is, when I have the sum, it's a sum of derivative of all terms. So it's 3t squared prime plus minus 5t prime plus 8 prime plus 2 over minus 2 over t squared. Square root of t prime, okay? Now here what I did, I basically, since I derive everything for plus, not for minus, I took minus 5 and minus 2 in the parentheses. But I didn't have to do it. So the next step is, we said just that constant doesn't matter. We can take out from inside of the derivative. We get 3 times t squared prime minus 5t prime. Well, I immediately gonna say that derivative of a derivative of a constant is 0. Just gonna write it 0 minus 2 times 1 over t square root of t prime. Okay? Now, what do I do next? Well, I have to remember the power function, how I deal with power function. And the way I deal with power functions is, if you remember, it was t to the power of n prime plus n t to the power of n minus 1 prime. So what does this formula tell us? Well, if I have t squared, it's going to be 2t. T give me 1. Now, 1 over square root of t prime need a little bit massaging. First, we need to say we need to convert it as a 1 over square root of t as a power function, and that is t to the power minus 1/2. And now we want to take derivative of this, and this is minus 1/2 times t to the power minus 1/2 minus 1, which is minus 3/2. Or if you want to rewrite this, we can say it's minus 1/2 t to the power of 3/2. Okay? So, and we're going to apply these things. Here we get 3 times 2t minus 5 times 1 minus 2 times what? Minus 1/2 t to the power of 3/2. All right? And the only thing that is left for us to do is to get the terms together. Which we can do a little bit lower. So our f prime becomes what? 3 times 2, 6t minus 5 plus 1 over t to the power of 3/2. And that's it. And that's it. All right. See you in the next video.